Okay, it looks like we are live, so welcome back. Today I'm going to be continuing to work on Kano Street. Yeah, it's been a few days. It's been too long, right? So, let's see, I need to refamiliarize myself yet again. But yeah, so I think I was looking, not that, Kano, right? This one. So I was having issues still with the structs, have not figured it out yet. Let me run this. I think we made some progress, but I don't quite remember. So, 2 and 9, is that what I would expect? Right, so there was an issue when reassigning it. That's where the issue came in. How you doing, Stan? What's up? What's up? Test is... Yeah, they're supposed to be the same. Yeah, so this one's supposed to be 2 as well. So that's what the issue is, right? It doesn't reassign properly. Don't know if you know... Well, I'm seeing you around a little bit, but I don't know you very well, you know? Yeah, so when reassigning the structs, we have some issues. So, if we have field reassign... Because that's, yeah, right here. So this is where it's going to be generated. Flashbang, alright. Give me a sec. I have a light, but it's not very good. I can, let me do something. I'll be right back. Is that a little bit better? Hopefully it is. I do not have very good lighting situation, so, yeah. Okay, yes, this is what we're doing. So it doesn't, let me think. It doesn't write over the existing one. It allocates a new one. And I think that's where the issue comes in. Right, yeah. Fascinating. Real. Yeah, so we allocate a whole new struct? Do we really? Because really it should just be pointing at it. That's sort of the thing. Let's see. So I kind of want to step through this. Let's open up one of these. That ends at C, right? So let's take a look at this field offset. We get that. We duplicate it, and we do this, and then yeah. So this doesn't allocate at all. There's no allocation here. But when we generate the expression, that probably allocates, doesn't it? Let me look. So this one successfully changed, right? We successfully changed what that one points at. But then when we set it to this, it does not. Right. So we allocate one here. So this is going to allocate, but then this is going to allocate as well. But what we need to do is, if it's reassigning it, we need to... As I do that. I need to remember how to do this. There we go. Okay. If it's reassigning it. So let's go to Gen Expert. Take a look at that. And then do we have a struct, right? That's what is here. So let me close this one out. Let me see. Yeah, because we allocate it regardless, but we're supposed to check if it's reassigning, right? Wait, why do I do this? If I get rid of this, I just do if reassign. I think that's what it is. It's reassigning, then you want to do that. Because we don't want to allocate a new one. We want to just modify the old one. But we need it to be on the top of the thing. So if it's... right. If it's reassigning, then we want to... This needs to be the opposite. I forgot. Sending a red circle live on Twitch.television website and pinging everyone who's interested in being pinged so the stream officially starts. Real. Yeah, I'll have to do that next time. I completely forgot. Thanks for reminding me. So we are. Otherwise, reassigning, then we need to duplicate where it is at, but we don't have the We don't have the pointer, or the location of it. Hello, hello, how you doing? Right, because we need to modify the old one. So, okay, you know what? If we place it, I need to. If not, we get a sign. Let's see, that'll build, right? Let me go back to build the assign. We need to duplicate it so that it's on top, right? We need the pointer to be on the top of the stack. Doing good as always. Glad to hear it. Actually, it is at this point, right? It is at this point. I think so. So let me try. Segfault. Okay. And let's actually yeah, seg assembles it. So there's 115. Okay, let's debug. Next. Let me see what instruction it's like that. Let's see. This does execute that, so. I can see what instruction now, I can figure out what it does. This thing goes hard. Oh yeah, I'll take a look at that. Hang on, I gotta give me a second. Hang on. Doing very well, thank you very much. Okay. Yeah, Brain C. So this is the Brain Freight compiler. It is French. Comment allez-vous? Okay. Is it ready? Like, does it work now? Does it compile? I can't pronounce French words. I took French, but I forgot. It does. Okay, I'll take a look at it in a second. I want to see where this segfault's at first. It did print something out though. Okay, it's segfaulted. So let's see where it segfaulted at. Also, don't look at the node. Right. Okay, so trying to write. So it doesn't. Bonjour. Banger. Yeah, I can't say it. Bonjour. Yeah. I might take a look at this. Should I do it now, or I'll do it now? I'm gonna clone it. I think I already have one, but I'll clone it again. Yeah. Actually, I already have it. Okay, I do. Sorry. No JIT. Yeah. Is that? Wait, that's how you're supposed to do it, right? Just make. Okay. Good. Alright. Nice. Help menu. Okay, so that will compile it, I'm assuming, and then I interpret it. So I'm assuming this is default, right? The default. Output the compiled file. Okay, let's try that. -o, and let's look at examples. Hello. Oh shoot, I wasn't looking there. Compile. Oh yeah, I want to compile. And do that. You have to do separate. There we go. Okay, that works. No default. Okay. A.out. Hello world. Okay. And we can actually look at the assembly. Yes. Okay, let's see. I'm not very good at assembly. I need to get better. Right, okay. That's the data stuff. And then here's the stuff, so we move that. Right. I forget what test does. French or English, something like that. Oh, and English, okay. Let's see, so then jump to adder 30, right? Address 30. French looks like Italian, or is, oh, okay. Man, this is a lot of stuff. It generates a lot. Wait, let's look at how it actually generates. That could be interesting. Just quickly, and then I'm going to get back to that. Let's go to compiler. Alright, so it does that. Compiler source code, yes. That is what I'm doing now. Okay, so this is the stuff it always generates, right? That makes sense. Okay, yeah, so increment, so we do move that, so that's the position, right? Which is there. Yeah, so you increment the position, right? Okay. Right. Increment, decrement. Input. Ooh, I want to try the input, actually. Let me do that. So I'm assuming that the, example, calculator. Yeah. 2 plus 5. Okay, actually, I have to. Let's do. Let's do. Oh, there we go. Okay. Nice, nice. Cool calculator returns up, but yes. Yes, indeed. I think the new lines threw it off last time. Or when I was, yeah. Okay, right, input. Very cool. Learning French, you're not programming. True, true. French is the best language for sure. That's a lie. It's obviously English. I mean American. Yeah, okay. Um, output, right? Okay. I want to look at the yeah, this. Yeah, it just jumps. Okay, that actually makes sense. And then exit, right? 60's exit, right? Yeah. Awesome. You check to make sure it executes properly. Always keep the pose in the ebooks register. Okay, only 137 lines for the compiler part. That's pretty good. I guess it's not a very complicated language, but very cool. Very cool. Thank you for sharing. I'll put the I'll leave this open so I can put the link in the YouTube video. Very cool. Okay. I need to get need to place the variable on the top, but the variable for the structure. So we need to well, there. Let me open this. Go to backend C and it's gen right that, and then we get we do this with the structure. So we're gonna do something like that. So let's see, gen state stack size and this struct we don't have a structure, so we have to get the structure. It got blocked. That's kind of funny. It blocked that because you said I personally don't like French, and it thought that was racism. That's kind of funny. Okay. You don't like. Okay. Ah, yes, we don't have that, so we need the struct block. Racist towards French people. Okay. Is it variable? Yeah, okay. Let's get variable. Like, someone can just pass it there instead of doing that, but I want to try that first. You don't like French fries. I think it's because there was like punctuation after it. French is rocket science, really. Did I really do that? No. Oh, shoot, right here. Okay, so struct name is var name, right? Or it could be, oh yeah, it's probably structure. Wait, is that right? Struct name is, yeah, okay. The structure. There we go. Got it. I'm not gonna even try to pronounce that. Okay. I cannot pronounce any words in any language except for English. And some, well, not really. Stack Overflow. Interesting. So it got stuck in some sort of a loop, we would see. We duplicate this. Well, do we just want to move it and then move it back? Hey, yo. We can all pronounce Spanish, sure. Hola. V into B. Wow. Wow, wow, wow. How did Stack Overflow? That's kind of weird. Let me think. We duplicate that. And then... Well, this isn't really... We want to write into that. Yeah, okay. That's not right. Yeah, Jen. Stack Overflow. Where's the struct? Right here. So if we're not reassigning, then we allocate. Otherwise, you just get rid of it. I don't think I need that regardless. That was kind of stupid. We generate the field, right? So nothing allocates in it. So we just sort of write into it, right? So this will give us the correct offset. Is that right? Wait, change structure field. What does that generate? Gen structure field. We duplicate. Is that just a thing we push? Yeah, so it's just the offset basically, and then we write into it. So that's right. That is right. So we're just writing into the thing. Yeah, so all of that should be fine. Assuming that it's the right variable on top, though. Assuming it is. Stack Overflow. Okay. Why would it do that? It's kind of weird. Remember, I was telling you that you were planning to make your own version of no build by Amista Zildin, yeah? Started doing it, and it doesn't have the build feature, but it provides some macros and functions to work with dynamic arrays, strings, and file buffering. Nice, nice. In German, numbers come from the end. So 14 is 4 plus 10. Interesting. Interesting. Let me look at that. Cactus. You have it on your GitHub, or is it not public yet? Yeah, I think that's good to have like sort of a library that is sort of general that you can use for a lot of things. C extended, is that it? Yeah. Yeah, okay, this does seem to be it. Very cool. I'll start. Yeah, I found it. Okay. Big cool, yeah. So reading files, all that stuff, okay. It's really use a checklist, but you only put the things that you already have done. Interesting. Okay. Find that. Right. Yeah, that's a good thing. I should make one. I should make one indeed. Need to update it. Okay. C-log. Ooh, okay, I like that. Very cool. Read entire file, nice. String builders, okay. Yes, very cool. I will make one of these at some point. Very nice. What is... yeah, I want to see... Well, that's not really gonna work. It's gonna... Does it just get stuck in the loop here? No, it doesn't. Yeah, it's weird that it was Stack Overflow. We should use GB. Debug. Yeah, it has already. Okay. to enable. And let's break on run instruction. And we'll run it with okay, let's do this. We can see what the instruction. So maybe I'll just display instruction. Allocate. I want to see if it gets stuck in a loop. Right. Okay, to add. Right. It prints it out a lot of times, but it changes. It seems to just continuously be doing that. No. Okay, so it's different. So we jump. Let me see. I might want to actually. Oh, let's see. I can disassemble it. So that probably looks very weird on the stream. Actually, the scrolling through it. Test. Okay. Yeah, I want to output that to test.as. Sure. I don't know I can build it, but I can look at it. Should I realize that this kind of messes it up, so we can't just compile it, but that's fine. So maybe it should be like a comment instead. BRB. All right. Yeah. So it's hard to tell where it would be growing from. Let's go to the jump to 68. So what is 68? No. Yeah, it says like a label basically. And then we jump to 85. Where we do this stuff. Okay. Yeah, I don't know why it would do that necessarily. Missing from no build is the possibility to allocate and deallocate arrays that aren't on the stack, but on the heap. So you create a DA heap alloc and DA heap free macros. Sometimes you need to return dynamic arrays from functions, but you can't return stack pointers. So what you need to do is allocate the array on the heap. Right. That makes sense. That makes sense. I should make a gen print so I could print it out, you know? And that just generates the print instruction. Yeah, I should do that. State. No, we just need print, that's it. Let's just go to gen push. Okay, for debug purposes. Actually, I'll put it above. Okay. I might not have it, the instruction. Well, no, it should. And yeah, that is just nothing, so we'll set that to 0. Get rid of this. And we don't have to increment the, well, we have to decrement the stat size. Because it does consume. So I just want to see what it prints out. Texan, how you doing? Don't think you're subbed. Perhaps not. Texan, been a while. Since you been on a stream. It's also been a while since I streamed, I guess, but you are okay. Ooh, is this? It looks like it's a pointer. It says the type is pointer, so I'm assuming it duplicated it properly. Right. Let's go down here. How you doing, Texan? How you doing? If I go here. Nice to see what it is, but I can't really do that. But that's a nice instruction to have. I don't know why I didn't make it before. Yeah, so this is a pointer as well, so that's right. That is correct. It's correct. You're good. Found an old Office desktop that has Windows 10 on it. So it can't be that old then. Well, I guess that came out in like 2014 or something, right? Hang on. I remember when it came out. 2015, okay. Almost 10 years, I guess. Making an Arch Linux machine. Nice. What are the specs? The specifications. What is below this? I'm not sure exactly what I would expect to be there, but I'd like to see. It's a pointer. So why is there a pointer there? Trying to think about why it would be there and what the order would be. There's another pointer below that one as well. Oh, I guess that consumes both of them, so that's not quite right. Runs Windows 10 means it can run anything on Arch. True. I don't know. It's just, like a computer that's 10 years old now is not really like maybe if you're doing intense gaming or whatever, but it's not you know, like you can do pretty much anything with it, but a computer from 2004 in or from 2000 yeah 2004 in 2014, it seems like a bigger gap, you know, like technology has not progressed as much. Yeah, so it's just pointers. I wonder how long you have to go for that. 5 and the integrated graphics, okay. So i5 from 2015. It's like the is that the 5th generation or is it a year behind? I don't remember. Another pointer. How many are there? And now there's okay. There's nothing after that, so that's all right. Well, actually, we could use this for. We do that. And I could use it for debugging it, right? We get a Stack Overflow still. Don't know. 1 sec. Okay. Yeah, so now we'll be able to see where it prints it at. JSON serializer. If you always don't have written a thing, but you discovered this book. Crafting interpreters, yeah. Very nice. Crafting interpreters. I haven't, like, I read a little bit, not a whole lot. It was good, though. Maybe I should read it. Finish reading it, you know? Let's see, so wherever we have the print is where we're gonna be. Print construction. Where are you at? Print. Okay, so there was the print. You know, we have a pointer, but we duplicate it, so we're good there. Push 1. Yeah, but it gets stuck in like a loop then. Does it print? It doesn't print again, though. It calls 70, then it ends. What is call to? So it changes it. So it like jumps there? Oh, okay, it's like calling, yeah, calling like it's a function. Okay. And it updates the yeah, the return stack, that's right. That's right. But it did just end there. So I don't know why it would Stack Overflow. If it ends. Unless actually that is set up. It's assemble. Yeah, okay. Yeah, because I do this. But I update it, right? Not assemble, but rather debug. Yeah, okay. But this, well... I mean, yeah. Oh, but we still, well... Less than program size. Yeah, I mean, that should be fine, I think. Go to the entry point. Yeah. It's not a pointer here. Oh, but that's printing it. Okay. Yeah, so that should be fine. So I don't know. I want to think. Let me get rid of this right now. That's going to say so I need to actually change the other one. Oh, I can't do that here. Gen into no, gen expression. Yeah, okay. Regenerate the allocation. If it's not reassigned, alright. Yeah, I need to variable last time. And that's cycles. Oh yeah, because I was getting rid of this. That was the point. Okay. And that, yeah, that just prints it out wrong. It's out wrong. Let me go back to here. So gen, let's get rid of that. And yeah, what if we do that? I'm just thinking it has like an extra element on the stack, but we can't pop it off because we need to modify. And we're writing into it. So we're writing a value into it is what we're doing. Also wrote 2 resumes. Nice. You live in Europe, and there's so much bureaucracy. Uh, you're creating. No, I'm just kidding. I'm joking. Creating a standard for resumes to be read, written, and distributed. All right. You had to change your American style resume to the Europass style. Oh, okay. 3rd gen i5. Interesting. Hmm. 3rd gen i5. I mean, that wouldn't be too bad, right? Like mine is where is it? Yeah, 2400. So it's actually older than that. Yeah, I have a dedicated graphics card, but it's not a good one. Might share it. All right. If you're comfortable with it, then that could be cool. But Optiplex 7010. Which one is mine? Hang on, it says here, right? Yeah, mine's 790. Pre-built. Yeah, they're good though. You know, like you can upgrade them pretty easily. Put in a graphics card, cheap one or an expensive one. Yeah, it's not too bad. Probably will need some more RAM though, but it depends. Let's give it back. Back to this, because this, we actually. Let's get rid of this again, because we do like here. Overflow. Yeah, why does it overflow? Optiplex noisy. It depends. Mine can get kind of noisy. But also I haven't. Yeah, I need to clean it out. It's kind of dirty, and it has old thermal paste in it. It'll be what you use until your good PC is repaired, which it still isn't. What are the specs of your good PC? Just have a laptop. Is it a noisy laptop? Let's see. So we don't have that. Call 70. And then we jump to 70, which is up here. And that's that. And then does it go back to a... Then it calls 28, though. Yes, it is. Okay. Still better than using Termux. True. Very hard. So we only allocate it in that case, right? Because then we modify the existing pointer. We write into it. It should be the same. Yeah, let me actually let's see what line is, well, let me add the print back, right? So wait, what? We don't have den print anymore. Where's it at? Where was it called at? Yeah, reassign. Okay, so I want to gen just so I can have something on my code. 1 TB of storage, 64 gigabytes of RAM. Okay, GeForce 1070, nice, and a 12th gen i5. That's pretty good. 50 good, a lot better than mine. So disassemble, and then I want to see where the print is at. I want to break around that. So, oh, it does this though. That probably messes things up. Oh shoot. Yeah, that's not right. How do I do change? Let me grab this, and I'm gonna change the print. I see. Okay, so I need to do 0. He's not supposed to have an author. still does though. Is that just on the output? But these don't. The OS is broken. Because the USB ports don't work? What the heck? Interesting. Is it something with the BIOS? Like it can't boot the motherboard? Yeah, well that shouldn't mess it up actually. We're looking at it. And then I want to go up to around here. So there's the right. So 8 is the size, and 2 is the value that we're writing into it, right? Because we're trying to reassign. Push 1, we swap them, and let me open H, and let's go to east, right. And what does that expect? What order does it expect? The size on top. Man, let me look at what would be on top. We have 2, 2, 8, and then we write. So that actually consumes that. So there's a pointer, 2, and 8, and that consumes it, and then it puts a pointer on top. And we push 1, and we swap it, so we have 1 and pointer. And then there's something else as well below this. So we can go back even farther. Motherboard problem, yeah. Let's go back here. So we do duplicate it. So this, let me look. Interesting. So how far do I need to go back? We have the pointer here, 8 and 3. And we duplicate the 3. 3 is where we... Indeed doesn't accept an offering. Okay. So that'd be, that grabs the pointer, right? You duplicate the pointer again. Push 0, and we add to it, so that's that. And then we push 2 and 8. We write, so that leaves the pointer on top. We push 1, and we swap them, 1 and pointer. We write that. That's not right. That's not right. Or does... Okay, this doesn't leave the pointer on top, does it? No, so it just modifies it. But it consumes the pointer. Consumes it. Okay. Let me go back. Boot up into the box. Welcome back, Cactus. How you doing? 8-3. Duplicate it. So we'll duplicate the pointer. And then duplicate it again. Push 0, all that. And then push 2 and 8. And we write, which consumes all of those. And we have the pointer on top. And push 1. Either way, though, that's wrong. Oh, no, it just interacts with itself, though, right? So it goes there. So we have 1 on top. We still need something else, the size. Let's go to, hang on, here. Swap 1. Right, so we don't have the size there? Is that what the issue is? Sent you the resume. Let me take a look. On Discord, I'm assuming. So you can get into the BIOS? Interesting. So I can open this on the stream, right? That is all right with you, Mr. President? Flashbang, kinda. Flashbang. Yes, yes. Okay. Yeah, it is censored like the phone and email. Right. Young specialist in computer science. Very much flashbang. That's alright, we can get through it. Boot sensitive. Yes. Okay. Low-level system. Compilers, interpreters, virtual machines. Nice, nice. Go. Python. C++. Kinda sus. Okay. Very cool. Docker, what the heck? Web dev? Web dev moment? Communication. Alright. Buoyancy. Do you have like the... I know that's the name of it, but... I don't know. You know, like putting a swear on your... on it. On the resume. I'm not sure. I'm not sure how it is in Europe. Right. Bridge Watcher, right? Yes, know about that. Languages. That's a lot of languages. Mm, isn't it? Yeah, I get it's the name. I get that, yes. But still. Very cool, though. Very cool. Mm, do we need the size to write? Because we have the pointer there, but we don't have the size at all. Background. Yeah, sorry, there's water running in the background. My bad. My bad. I can't do anything about it, though, so it is what it is. I'm going to close Discord now. I don't want that open anymore. I'm talking about Texan's computer that does not work. Let's see. I need to push the size onto it. But what is so size that we're writing is just the size of, let's just push 8 for now. I can't do that. And it's segfaults when you do that. Okay. Let me right here and build it again. And let me open the text chasm and go to the print again. And let me go up here and I'll just break like right here. Break on 90. Okay. Now break 90. Okay, so we're there. Page 3, do that, and there's gonna be a print coming up. I wanna see on the stack side. Let's print the whole stack. We have 8 and then a bunch of pointers. Okay. That's actually called right. No, it's not. Okay, so that's before calling right. So that is not right at all. So that is an issue. So we have several of them are the same. Let's quit it there and then break on 90 once again. 4 in that case. So that is not right. I don't know why it prints that out. Stack side. Print 5. Yeah, so we have a bunch of pointers. These two are the same, so I think the duplication worked. We have the 8 here. Yeah, but then we duplicate that. Duplicate the 3. Wait, just not just duplicate the top? Where did the 3 go? What? Where did it go? I don't understand. Now there's a 0. Right, that makes sense because we pushed that. Sprint 3. 3, so we only have the 3. And the, because we undo. So we grabbed the third one. Right. So it was the one right below this. Oh, no, it was that one. Okay. Yeah, so 1, 2, 3. So that's the one I grabbed. Then we duplicate the top again. Right, so that is not quite right. Because then we have 2 of those on there. Then we push 0. And we add to it, right? So that's just adding to the pointer. And that's not work because there's an issue with that. So we need to do it after that one. So print 3. I'll fix that. Just not now. So we have that. We push 2 and 8. So 8, 2, and pointer. So that would be right in that case. So we swap with 1. Yeah, but then that's going to be wrong. Yeah, so this is not right. So we have, that's the size, I guess, to right. And that's right. But then we have the pointer below it. So we need the, what is the other thing? We need the data to write. So we don't have the actual data here. Oh, but the data is a pointer, yes. So that is right, yeah. But we're writing the same thing, and that's not right. Wait a minute, I might be very stupid. We want to generate the offset on... Oh, shoot. Yeah, I'm writing the pointer into itself. Let me get rid of this. I'm thinking. Right, what does this leave on top? The field offset. The offset, right? Gen field offset, right? So what's the last thing there? So we push that on top. That's the size. We want the pointer there. Okay, let me rebuild it and step through it again. In DB. And yeah, so we will break on 9, and we'll go here. Next size, so we print 3 there, so we have 8. 2 8s. That's interesting. Yeah, so this was nothing. That's not right. That's not right at all. Push 2, push 8, right. Yeah. So that's gonna segfault, yeah, because that's not the right pointer. So why was it like that? What? We just added 8 and 8 together. Yeah, because of this. Because this is the size that we leave off there. But we need the pointer as well on the top of the stack. So we do that, but then we have to add. Well, but this gets consumed. Where's gen offset? Push add. Right, okay. Push and add. So that offsets it. Then we push the size. But then it's not there. Gen date state and then gen print state. Put that there. We need to add like comment, but and put it into desktop as a. Not even reading this. Doesn't recognize that. Yeah, broken OS. Yeah, that's not easy on. Then we print there. Yeah, so 80. Well, before 80. Let's break on 7. Well, only right here. 71. We duplicate this, and then we push 0. But we're duplicating the topmost 1, which nothing's going to be there. I'm trying to think, but, get rid of that. Field offset, so we generate that on here. And that's right, because we have this is the pointer. We add the offset to it, but then we push this, which is the size. And that was very loud. So the issue really is that it doesn't recognize the USB stuff, right? Right, the offset, and we push the size. So that's what we have. We have the pointer and the size. Then we don't have that. We're gonna get rid of the printers because I need to do that. Okay, break energy. Okay, yeah, so that's not right. So it's before this that we have an issue. So we have 8 there. Then we allocate, so that ends this one. So we have these. Wait, oh, that consumes it because we're pushing the amount to do that. Print 1, so we have a pointer there, and then we push 8. We allocate again. Print 2. So we have 2 pointers on the stack. I forgot to break on 9, so that's what it is. Okay. Print 3, so we have 8, 8, and that. But then we try to add them together. So we get an extra 8 there. Wait, is that because I... hang on. Is it because I did... No, I did not. Why does it do that then? And this one. It shouldn't be because it's in here. But we get the variable, but that doesn't generate an instruction, but this does, right? Does it? True and false. So how does it get to that point? I don't quite get that. Oh, shoot. Okay. It's because we don't have the... Well, we don't have it on top, but why don't... Because this is an issue with that one. So I need to actually break down like 80. Look at that. Native. Turn. Let me disassemble it because I need to sorry, there's more water. Sorry about that. Change priorities, right? I was with UID blow. True. Very true. Alright, let's go to 9. Right. So here, well, this is really 89, but that's fine. Let's see. Do I want to go to this one? Push 0 and we add. So this indude must be it. Let's break on 85. Okay. Indude. Let's print out these. So we have 1 and that. Push 0. We're adding 0 to that. Okay, so that's fine. To work runners, so we print. Let's print all of them. Just have a bunch of forms. And they're all the different structs. And some of them, these two are the same because we grabbed value, right? Duplicate it. So then we have. Why is there an 8? We push 8, but then we. Oh shoot! Wait, what? What about Gen? It's not from this, right? We do that, and then yeah, none of them generate duplication. So why does it do that? Because that causes some issues. Because we have this, right? And now we're adding 0 to 8. And we cast that to a pointer. So that's how we get to this. Right, and that is not right. Go back to that. It's 85. Make 85. 3. Okay. 0. We add that to there, and then that is fine. But then we push 8. Push 8. Bullet pointer, push 8. And then we duplicate the 8. So why does that happen? Call this. Do that. And then the Gen Expert does something. Expert struct. What is this push? Gen structure field, and then that duplicates it because it expects it to be on top, but it is not. So we need to swap it. Is that would be what it was? Okay, hang on. I'm thinking here. Skip the question there on me. Sorry, it's hard to keep up with it. Oh, how hard was it getting used to TMUX? Not very hard, really. I'm not very good at it yet. I don't know a lot of the things. But most of it, it's like Control B, right? That's the thing, and then you just do a command. So like you can make a new one, Control B and C, and you can delete it if you do Control B, and then let's see, it's like you do the ampersand, and you can kill the window. Yeah, stuff like that, and then Control B and %sign does this. I always use the default ones because it works fine. The only thing I changed was having it start from 0 on the windows, you know, or started from 1 rather than 0. Okay. Yes. Send construct field. Right. So let's just do that. Swap that. Well, maybe not here, but instead swap it there. Nope. There is no swap. So let's just 0 does the top one, right? I believe so. Fine. 3. So we have 8, 0, and 8. See, but then we still end up with that. What? Yeah, so we didn't even swap them. Hang on. Oh, shoot, because we need to do 1. That, okay. So 0 just doesn't do anything. Okay. Makes right. Oops. I cannot fight. Okay, so that's closer, I think. I think you can change it. I've been looking into it, but I believe you can. I believe so. Yeah, it looks like you can. Yeah, you just have to change the content. I've gotten used to it though, so I just I don't care about it. Right. So let's print something out now. It doesn't say vault until after that. That's closer. Let me run this here and break. Let's break on 90. Well, let's break on 85. Yes. That's 3. So we have pointers there. Push 0, add to it. Then push the 8, and we push 1. Oh shoot, but then we swap there. And we don't want to do that, do we? Yeah, okay, we do want to do that. Hang on. Not quite. Because now that swaps... Wait, what? Consumes this one, and it swaps 8 with 1 below it. Then we duplicate it, we push 0, add, and that consumes it. And I mess it up. Okay. We have those two on top. Right, and we have 8, 2, so we're writing that into there, and that's right. 3, and then we have that, and we have the 8 below it. So we don't need the 8 below it, though. We don't need that. Swap them. So then we have the 8, but then we're writing... Oh, yes, that's right. So we're writing this area into that one. Is that right? Is that what we want to do? No, we don't want to do it like that. Because we want to write the... Well, hang on. If we write that, really we just want to modify it. Yeah, so we don't have to do it. Hang on. You don't have to write the data into it. You just have to write into the old pointer. So don't do this. Let me think about it. So we want to duplicate the pointer, which we do here, and just write the new value into it. And this is the value that we generate by modifying it. And that's all that we have to do. We can just stop there. We don't have to do any of this. Hang on. We don't, right? Wait. Because when we call that, it writes into it, and that's it. It's still segfaults, though. Checking Tim source code. Vim also has a nope instruction. Why is it there? So it just skips. I use it like well, something nice about it is that if you have a bunch of zeros in a file, like for whatever reason there's zeros, then it just skips over them. You know, it doesn't create any issues. And I also use it for labels, you know, just to know where a label is, because it makes it easier to read when you disassemble it. But I don't know if there's a more technical reason to use it. The USB worked. Bruh. Is that not right? Oh, do we have to consume it, though? Might have to. Let me do this, and... There's no print in there, right? Yeah. Yeah, it still is there, though. DB text, Wait, we click on 85 again. Print 3. So we have those, push 0. Yeah, so we're just adding 0 to that, so that's fine. 8 and the data, running this data into, but that's not right. Duplicate that. Push 2. You're running 2 into that, so that is right. Push 3. Grab this one again. We're reading the data from it now. Okay. Why are we reading it? This does not look right. I don't think we should have that. So that is an issue. Whoops. Okay. Just face this problem, bro. All that time. Consume the engine. Trying to think. Why are we reading stuff after this though? Not in here though. So we generate the offset, and it's just a pointer. So then we just write into it, which we do here. Yeah, because the pointer's on top, so we write into that, and then we just have to remove the pointer because we don't need it anymore. But we modified it at that point. So that should be all that we need there. Because we don't have to write into it. Oh shoot. Oh shoot, but actually that's different though if it's a structure already. Is it? It's not really. I'm gonna go with that for now. I'll leave this temporarily. But I think the next thing has some issues. Let me break down that again. 3, we have that. And at what point do we... Right, so after I run this, I cannot. That, so there we go. We have those two, we push 2, push 8, and we write. Backside, print 3. So we have those ones. 2, 8, and a pointer. Right, so we write into that. No, can we push 0? Oh, shoot. Okay, 2 was duplicating. Alright. Yes, we're adding 0 to that, that's fine. We have that in 8. Stack size just keeps growing though, you know? We have a lot of duplicated ones. Well, I guess not really, no. Let's keep going. Read. So we're reading 8 bytes. What is the... That's not right, hang on. Sorry, the indentation's still messed up. DB stands for debug. Yes, it is debug. No. Well, it's just, it is a, what's it called, like a flag, you know? It's not an instruction or anything. The type. Oh, but the type is 8? We have types. 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it is pointer. So that is actually right. Okay, so we read that. So we have that, and that's not right. Because we don't want to read that. But why are we reading, right? What are we generating as reading? Then read. Do we have something like that? So I can know what it would be. Like, what do we call this? Array. Field array. We don't have that. Oh, in the field. Okay. It's a little complicated. Dash dash verbose. Field offset. Are we calling this? Is this what it is? Just let's see if we are calling that. Yes, okay. Why are we reading it? To get the value? Yeah, and I guess we're getting the value here, aren't we? With this. So this should get properly reassigned, but now we have an issue with this. When we read the value, it doesn't work. Because it reads the wrong value. Oh, but it's reading 2. But it shouldn't be interpreting as a pointer, so that's the issue, actually. Because it's the wrong type. Okay, I see. Because we're getting that. But we want the field type, right? We're getting the type of the structure, which is a pointer, but not the field type. Okay, hang on. Let me think for a second. Where do we do that? We push this. Data I. Is this where it's doing that, though? Could be from this one. Let's try that. I'm gonna get rid of the other gen brain. Then I can take a look at what it's doing, right? Yeah, so type is int each of those times, and that's right. Yeah, but we want to know what this type. Let me look at it. That's okay. Okay. Print. So we push 8. Yeah, push 8 twice. The type is pointer here. This is type as pointer. Why does it do that? Okay, no, automatically appends a closing parentheses, brace, or bracket after you type the opening one. My Vim does that. So that is why I do it, because I like that. I could make an option to disable it, though. Could do that. But each time it is 8. But that's not right. Sounds like you can contribute to Kano. It really wouldn't be that hard to add. Oh, it's just like a flag, basically, another flag, and then just wrap the indentation code in an if statement. Yes. I thought everyone liked that, though, so. An if statement, yes. I think I just need to refactor the structures entirely, because this is too convoluted, you know? So maybe I should do that. I need to do more research, though, on how to actually properly do it. I should read the C source code, like TCC. That could be cool. And then I could, get an idea of how that does. I mean, obviously it's not gonna be the same as C, but a more professional way to do it. Because it really sucks how I'm doing it now, I'm not gonna lie. And I just have to add more to make it actually work. Right, and I have different things for, like, different ways of razor handle and stuff. Not sure that that's a good idea. Does everything probably broken. Right. The print statement, the print option is nice though. Nice to have. Yeah, I need to figure out a better way to do that. So I guess that's pretty much it then, for today, because I need to reconsider some things. Right. Yeah, I guess so. Alright. It's good. It's all good. Yeah, really, the structures and arrays, I don't think I handle them very well. So I need to just I think everything else is pretty good, like how the variables work, and a lot of the other stuff, but it's mostly those, because I wasn't really sure what I was doing. Yeah, I think I'll do that. Okay. Yeah, so that'll be the end of today's stream. So let me kill the session. Yeah, so thank you guys for watching, and I'll see you next time. Goodbye. Goodbye, Stam.